My name is Robert Franklin. I'm conducting an oral history interview with Ted Anderson on May 11th, 2017. The interview is being conducted on the campus of Washington State University Tri-Cities. I'll be talking with Ted about his experiences working at the Hanford site. And for the record, can you state and spell your full name for us?
Okay. Theodore DeLynn Anderson. That's TheodorDahlin
Great, thank you so much. And you prefer Ted?
Yeah,
Right?
yes.
Okay.
Well, there's a little story here to that. Theodore is a compound name. Theo, it's from the Greek. Theo is God, Dore is gift. So Theodore's gift of God. Ted, on the other hand, means to spread hay or manure. Okay.
That's good. So Ted, tell me, how and why did you come to the Hanford site?
How? Well, I'd had on-campus interview in 1967 with a representative from the site here.
Oh, and where was this interview?
University of New Mexico.
Okay.
I didn't take a site trip, but then I went to work for DuPont back in Virginia, and became somewhat unhappy there. And having gone to school in Albuquerque with all sorts of desert basically around, and mountains and stuff, and that's where Hanford sort of is. So I give a call to Dr. Watson, who was the recruiter here, and said, you still interested in me? Oh yeah, when can you get here? So then came cross country with my wife, my daughter, and 2 cars.
Wow.
So that was 1969.
And when you were, and so you did which degree did you do it?
Chemical engineering?
Chemical engineering. And it was a bachelor's?
Yes.
Okay. And so, so what job did you come to do at Hanford in '69?
Came to work at Hanford. They were going to put me, well, I went to work in tank farms.
Okay.
But when I started out, all I knew was I was going to work at the nuclear reservation, which, of course, at the time, there was a lot of secrecy. So they're not going to tell you a lot till you get here.
Mm. So not knowing much about what exactly you'd be doing, what attracted you to come work at Hanford?
Basically, that it was desert like New Mexico, and it was something new and different. I was probably a bit curious. I liked being in New Mexico where you could see for 50 miles, rather than in Virginia where you're lucky if you could see for a quarter of a mile. So came out here, and of course when we were first coming down from Spokane, and it's June, late June, coming up on July, and the wife is starting to look at all this brown country because it's desert, and she's sort of looking at me like, where have you brought us? But yeah, anyhow, that's how I got here.
I think I and my wife had the same experience when we first moved out here.
Yeah.
Where am I? This is not the Washington I signed up for.
Yeah, where's this Evergreen State?
Yeah. So so you eventually went to work in the tank farms, and so I'm wondering if you could tell us, quickly kind of what the tank farms are, but then what your duties were there.
Well, there was radioactive waste that was created through the processing of spent fuel to get plutonium, and the aqueous waste went into underground tanks. They're nominally in the neighborhood of a million gallons. The first ones were 750,000, and later ones they're actually a full million gallons, 75 feet in diameter. And they were basically concrete tanks with carbon steel liners. So that's where the waste went from reprocessing.
And were these the tanks? Were these tanks from like the World War II era on?
Yes.
Okay, so these were the single shell, the what are known as the single.
Well, later on there were double shell tanks, but initially what I was looking after was, I think there's some, I don't remember if there were any double shell tanks when I first started. There may have been, but.
And so what was your job with the tanks?
I was shift engineer.
Okay.
and rotating shifts. There was a number of units. I had specific responsibility for 2 of them, which was ITS, in-tank solidification units number 1 and 2. But I covered the entire tank farms, both the east and west area. So anytime there was issues with waste transfers, they had another evaporator, 242T, over in west area. So I would make my rounds of tank farm operations. If there was any problems, try to troubleshoot. If it was something I couldn't troubleshoot, then I'd make a little note of it and turn it in to the powers that be at shift change.
And which contractor was running the tank farms when you?
That was the Atlantic Richfield Hanford Company.
Okay. And so, what was the primary? What was the goal of managing? Like when you say managing the tanks, like what was the what were the goals of that? What were the outcomes of tank management?
Well, we were still producing a lot of aqueous waste. I mean, Pyrex was in full operation. B plant was processing waste to remove the cesium and strontium to try to get to a point where we could solidify waste. And so, yeah, we're trying to accommodate the waste from, this is Cold War, of course, and so there's some pressure to make plutonium.
Sure.
Although I think we did way too good a job at it. Eventually, when you think the first bomb was talking about grams, and eventually we produced something over 16 tons, we learned altogether too well at it. But anyhow, for just the start of things, we're trying to make space for the aqueous waste that's produced, primarily from fuel reprocessing, but also from other processes.
Right, because there were several processes of the waste, right? There were several different distinct chemical processes for processing spent fuel.
Oh yeah. The first was what was referred to as BIP-04. That's bisphosphate, BIP-04. And that they were just after the plutonium. So that was the initial thing. That's how we got our plutonium for the first bomb. Mm-hmm. Then they decided that there was an awful lot of uranium that was gone out with the aqueous waste. So they had, among other things, what they called a heavy metal recovery program, where they would reprocess the waste that was already in the tank and try to remove the uranium so it could be made back into fuel assemblies.
Were the tanks designed for the waste to be pumped in and out of them in this fashion?
They were made to transfer between tanks, recovery, because partly what went out was liquid and part of it was solids, and the uranium was in the solids, so you had to have some sluicing in the tank. And no, the tanks were not built with the idea that you would remove solids from them.
To reprocess.
To reprocess. We did, but then there were some other things that had what they called a space recovery program. So they hit the waste in several tanks in east area with a cyanide solution that precipitated pretty quantitatively the radioactive material out. And then they pumped supernatant across the road to what was called the BC Crib area, which was open trenches, a specific retention site. The waste was pumped into there until they had specific retention meant they didn't want it to go all the way to the groundwater. So they calculate what the soil column could hold, and when it reached that level, they moved it. So that was another thing they did. As I said, B plant was in operation when I got there. There they were separating the strontium cesium from tank waste and encapsulating it. Mm-hmm. The Waste Encapsulation and Solidification Facility, WESP. Again, the idea was that eventually they wanted to solidify the tanks with the waste inside, and that was going to be the permanent disposal. Which, I'll tell you a little story here. The initial work they did, they took samples out the tanks, very small samples because it's hot radioactively, and they sent it to what was in those days P&L. That's before they got the extra N.
Right.
And then they concentrated it. They said it was concentrated by a factor of 4 and allowed to cool. It became a solid mass. And then they extrapolated that, or tried to million-gallon tanks. It didn't really work that way. There was multiple challenges. For instance, ITS-2, which was in tank 112BY, used big immersion heaters, like million-watt immersion heaters, to heat the liquid in the tank and boil it. Then it was moved from 112BY to a series of what they call bottoms tanks, where it was supposed to cool and solids settle out, and we're going to create more space for more waste, so we don't have to build more tank farms. Trouble is, it didn't really happen like that. You had selective precipitation. It didn't just set up all at once. Certain compounds would settle out, and they formed a crust on top of the liquid, which didn't help with the cooling, because the idea was that this hot stuff would go out into these tanks, and the tanks were ventilated, and you would evaporate more water. And so that didn't work. Then they put in airlift circulators, which were supposed to open up the surface, and that worked for a while, but eventually you get down to maybe 10 feet in diameter for the airlift circulators. So it was an ongoing challenge. And there was some really funny chemistry. For instance, in 102BY, which was the in-tank solidification unit 1, and I was there, I was the charge engineer, where we took a sample, sent it over to the 222S lab. Well, the sample, you didn't want to get real close to it. We ship it in these pigs, lead shielded containers. Went over to the lab, and I filled out the sheet that said, here's what the characteristics were, which was a clear yellow liquid. Well, then I get a call a couple days later from the lab that says, your sample sheet says it was a clear yellow liquid. What we've got has lots of solids in it. It's, well, yeah, it cooled. Okay, so, put a magnetic stir in it, and this is all going to happen in a hot cell. And put the magnetic stir on it and heat it up. And Steve Buckingham was the lead engineer then, lead chemist, Bucky as he was fondly known. And he called me up and he said, been on there for 2 days, still full of solids. So what had happened apparently was there was an irreversible precipitation. In other words, it wasn't just a compound that precipitated out that could be redissolved. There was a chemical reaction that had happened when it cooled. Very strange material, because there are so many chemicals in it. And we tried to replicate the waste so we could do cold testing. They were never able to get both physical characteristics and chemical characteristics in the same surrogate. You could mimic the physical characteristics, you could mimic some of the chemical characteristics, but you couldn't do both in a cold sample. So, yeah, some really strange stuff.
Yeah, no kidding. Wasn't in this precipitating out of water, I understand that to kind of get the material to be more of a solid, to save space. Would that water have carried any kind of radioactive traces with it when it was precipitating out?
So we, as it came off, like 112BY, we had condensers to cool it down, and then the air was put through high efficiency particulate air filters, so that again, what was released had minimal, if any, contamination in it.
Sorry, go ahead.
So the HEPA filters were nominally good for about 10 to the 6th decontamination factor. So, yeah, it cleaned up the air pretty good.
Well, that's good. What would be done with these filters? Because I assume they would, after a while, they would be radioactive themselves, right?
Oh, yes, yeah. And you could flush them, but ultimately they didn't really, there was things that plated out on them that would increase the delta pressure, DP as it was known, to the point where you can't clean them up enough to. And they were only good for like maybe a 6 inches DP before they could be ruptured and pulled through by. So yeah, another little story from, there was something called AR Vault, which was used when you recovered stuff from A-Farm, AX Farm tanks. It would go into AR Vault. They were recovering sludge, and when they got enough of it, then they would pump it over to B-Plant. Okay, and the way this was set up, there was 4 tanks in this semi-canyon building. There's a big open door at the end of it, where if you needed to bring equipment in, you could. Okay, well, there's cover blocks, so if you once you bring the equipment in, you close the doors, and then you can take the cover blocks off. And okay, so there's 2 different speeds on the HVAC, heating, ventilating, air conditioning system. One was the normal, when that door at the end of the thing is closed, and the other was when it's open, it really crank it up. So I was shift engineer, and talking to the operator there, and at that point, AR Vault was not actively being used. There was a little lull in our processing. So he's running on to me. He said, they really need to change those filters out on radiation levels, not just wait for the differential pressure to go up. And I said, yeah, good point. So I wrote up a little, what we call DSIs, don't say it, write it, and left that for management. Said, here's my recommendation. Well, about 3 years later, I'm working on low-level waste management, and I heard that they, quote-unquote, sucked the filter at AR Vault. I thought, oh, well, okay. Not too long after that, I get a call from somebody that said, just reading your memo here, why didn't they take action on that? I said, did you look at the date on that? Oh, that was quite a while ago. Because what had happened is that with AR sitting there basically not doing a lot of processing, but you're still ventilating, still getting some particulate, it kept loading the filters, but the airflow rate was low. So now they're going to open up the canyon doors, and they jack the airflow up, and of course delta P is not linear. It's an asymptotic thing with airflow. And so when they jacked the airflow up, it sucked the filter. Okay, well now the filter was supposed to be contact maintained. That is, you could go in and manually take it into a disposal container. Well, as the operator had pointed out, they didn't change it out on radiation readings, and now it's too hot to do it manually. Okay, so now what they had to do, and this is, we're talking about a rather large assembly. So now what they had to do is go in a considerable ways away from this filter assembly and open up the line and build a parallel one and reroute it around to go through a whole new filter thing. And then they had to take the whole old filter thing out and bury it. So, you know, it's things like that there tended to be, you know, not a lot of thinking about what the potential is. So anyhow, one of the little stories.
Oh, that's great. That's a great story. So how long did you work as a tank farm shift engineer?
Well, initially I did it for, let's see, 69 to like sometime in 72.
Okay. And
then I was on days for a while, and I think they thought I was a bit persistent on some things, so then they, you know, please don't throw me into briar patch. They put me back on shift work. I like shift work. You know, you can shop when the stores are not crowded. Things like we had a popcorn club for the operators, and of course you know, you hang out with the operators. And so, yeah, they'd buy popcorn in 50-pound bags. They'd buy popcorn oil in 5-gallon things. You paid a couple bucks a month. If you wanted to make popcorn, you went down to CR Vault, or CR Tank Farm, rather, and got popcorn and oil and went back to where your lunchroom and made popcorn. So, I mean, there's a lot of camaraderie when you're working with people like that. And so, yeah, I liked working shift work. When my daughter finally got in school, it was not quite as much fun because she and my wife could sort of adjust when she didn't have to go to school. But then when she was in school, it started getting a little more challenging. But anyhow, I went back on shift work, worked on shift work probably till, I'm thinking early 75, and back on day shift again. And finally, August of 75, I decided I'd had enough, and I quit.
So you quit the tank farm?
I quit the job.
Quit the job.
Yeah, I was at that point farming quite a few acres and had some rentals and was looking forward to just doing my thing. Thank you.
Yeah. Was there a particular incident that led you to quit, or was it just? Or I wonder if you could kind of describe what happened to come to that decision.
Well, one of the problems is that, again, management tended to be short-sighted, as in the CR Vault incident. And I was told that my resignation letter, it was probably at one time or another in hundreds of files out there because people thought it was such a wonderful letter. But, just very short-sighted, wouldn't listen to good technical advice, and again, not well managed. And so I basically, out of frustration, just said, I don't think I need this.
Mm-hmm. Do you think that was particular to the tank farm, the tank unit, or would that have been like a kind of a contractor-wide issue?
To some extent, it was contractor-wide. I think the tank farms may have been, but then again, maybe it's just because I had that personal knowledge of tank farms.
Sure.
Because there was other things that, that it was always a short-term solution. Not looking out and saying, okay, how's this going to work 10 years from now, 20 years from now? It was more like, how's this going to work next month? So anyhow, yeah. And of course, eventually then I went back to work for P&L as doing the initial waste vitrification demonstration.
And so tell me, how did you come to go back to work? You said you wanted to kind of do your own thing but how did you end up coming back to waste management?
Well, I was drawing unemployment because another story, I quit, and then I filed for unemployment, and ARCO was going to dispute that. And I thought, oh, good, because I had, lots of documentation of not being employed to use my chemical engineering education, which is, if you quit with cause and you can demonstrate the cause, you get unemployment. You have to wait 7 weeks, or you did then, but, So I had done that, and then the wife and I were supposed to be hearing in, I think, December, and the wife and I had gone off to Hawaii for a little bit of a vacation. Came back and lived in Benton City at that time, which had no home delivery of mail. It had to be a post office box. So we went up to the post office box, and here's a stack of unemployment checks. ARCO dropped there. Apparently they decided that they didn't want to get any legal go-rounds. So then I drew unemployment for as long as I could. And when I got into my final 13-week unemployment thing, they were really insisting that I do some serious interviewing. Of course, I have to confess that one of the things that I thought made me unemployable was I had tried to unionize the engineers. Yeah. Okay. So anyhow.
Yeah, that kind of will sometimes earn the ire of management.
Well, they wouldn't have dared to do anything like firing me, but they wouldn't have dared to do anything like hiring me back.
Right. Right.
So anyhow, then I was interviewing with Jack McElroy with P&L, and they wanted me to help with it. They were doing a waste vitrification demonstration project, and they needed help, and I had a lot of background. And he said, "All I ask is one thing: promise you won't engage in any organizing activities." And I said, "You got it." So then I was working for P&L.
So sorry. So I'm very curious. I want to go back a bit because you just mentioned this unionizing thing. Now, what led you to that kind of activism at when you were at your job at ARCA? Why did you try to unionize?
Because other people were having the same problems I was. Good people tended to be leaving, so your overall quality of the people you work with can tend to go down with times. And there's a lot of people that, you talk and they talk, but they don't do anything. Mm-hmm. And I've never been one to, if you're going to talk the talk, walk the walk. So I got together, what was it, Hanford employees. Anyhow, we had a whole bunch of people with names that were interested in doing this, and we quickly decided that we really couldn't afford to do this if we were being challenged in court because we didn't have the resources. Mm-hmm. So then we contacted some professional unions. For instance, Boeing, their union, their engineers are unionized, and we talked with them. Campbell Soup Company, of all things, was unionized and had their technical people in that. So yeah, we were moving down that road, and one of the things that really stopped us is we didn't want to be sucked up into another organization. Mm. And it was beginning to look like you're going to have trouble maintaining your independence if you get the help you need to fight the corporate people. And
right, because they're going to want, another union would want your membership,
yeah,
to bolster their ranks.
And of course, none of them really understood Hanford, which was going to be another problem. So that was basically, we said, no, this is it's not the right time, maybe it's not, But of course, we apparently had scared the tar out of management because, I was told that there were some really serious conferences down in the federal building, fondly known as the Fed Shed, with people wondering what to do if we actually officially tried to unionize.
Right.
I didn't know I'd cause all that consternation, but
guess word about you had spread.
Well, there was three of us. Trying to think of the other two were. Can't think of their names just offhand, but we actually were on TV, interviewed. This is what we're thinking about. Okay, but then I'd say, these are engineers you're working with who tend to be horribly practical. And, you look down the road and you say, I don't know how this is going to work. And if we give up our independence, I don't know if we're going to be able to attract enough people to really get a viable vote. So we finally said, okay, heavy sigh. Well, meanwhile, they made some changes for the engineering because engineering wage increases had been lagging the craft workers, the union members. They were getting like 5-6% a year, and we're getting like 4%, which is one of the sticking points, that if the squeaky wheel gets oiled, so
sure.
What's us be a squeaky wheel?
Do you know of any other? I assume you did your research in kind of some of these other companies. Did you find any other atomic sites that had engineers that had unionized?
Not that I recall, no.
Hmm.
There's one other professional union we talked to. I want to say that maybe it was 3M, but I don't recall. But I know Campbell's and Boeing were the two for sure that we talked to.
Yeah, Campbell's is very interesting.
And,
I wouldn't have.
And United Auto Workers also. That was another one. Their engineers were unionized. So yeah.
Cool. Well, thank you. That's very. I had not heard of that attempt before, so that's interesting.
Oh, okay. Well, good.
One last question to you before we go to your time at PNNL about the tank farms. I'm getting the sense that from your perspective that there was much more of the tank waste management at that time was more about finding more room for waste to continue production than it was about ensuring the safety or kind of the safety and stability of the tanks. Or it seemed like there was much more short-term focus than long-term planning.
Oh, yeah.
Because that waste would have to sit there. Was there any talk of where that waste would go, whether it be a repository or what would happen?
No, the assumption was that it was going to be solidified into tanks and left.
Oh, really?
Yeah.
Okay. Was it from an engineer's perspective? Is that a feasible? Would that have been a feasible project?
It would have taken, for instance, what you wound up with this successive evaporations is a very caustic solution. And it's, when it cools, it doesn't really solidify, it just gets thick.
Mm.
Sodium hydroxide, okay, basically. Why? So one of the things that was talked about was the fact you get a tank to a certain point and you load it up with grout, cement, basically.
Mm-hmm.
And then we also did some experiments with fly ash because that would absorb liquid. But again, in those days, there was no talk of the waste coming out of the tanks. Vitrification was not on the table.
Had there been any? Had all the tanks maintained their stability at that point? Had there been any?
Oh no, there was. Tell you the story about the tar rings.
Okay.
Okay, say these tanks were basically concrete tanks with carbon steel liners. Okay, well, we were developing in-tank photography. A good friend of mine, Jerry Everett, was the lead on that. He was with PNL, photographer. And so they developed techniques for lowering a camera into the tank and rotating it. So you could build a montage of the interior of the tank. Well, about the second tank they did that to, you could see there were black rings at certain points. Okay. Well, the tanks between the carbon steel and the cement was mastic, as they called it, tar, because that was meant to basically seal it tight between the. Okay. Well, now if you're seeing tar, that indicates that the carbon steel integrity is gone. Okay. And there was all sorts of theories about how that could happen. There were potentially, they talked about microorganisms that could withstand the radiation and oxidize. And of course, young engineer, and I'm expounding on some of these to one of the old operators, and he said, "Iron-loving biota my ass." Oh, what happened? He said they just dumped an unneutralized batch out because the processing was done on the acid side, and then you hit it with caustic so it would be compatible with the carbon steel. And I said, so, if you didn't get the caustic added to the batch, it would go out to the tank, it would potentially float on the surface and eat up the carbon steel. And I said, so is that written down someplace? And he looked at me like I was an idiot. He said, hell no. I said, what did you do? put the caustic down the pipe after it.
But no mixing.
But no, of course, then the record shows that you've used caustic. I mean, we used however many 100 gallons, and Okay, so there's stories like that I'm sure nobody really would want to admit even today, but that's what the operator said occasionally happened. You send an unneutralized batch out, and of course there was other things that went on, like SX Farm over in West area. Had initially been bottoms tanks for redox, and then they decided that they were going to try to use them further. And redox was the first solvent extraction predecessor to Purex. So the material that was coming out then was a lot more concentrated as far as radionuclides. Well, they were in a hurry to build the SX tanks because redox is coming online. You need a place to put that stuff. Okay. And so the earlier tanks were built with a slightly convex, concave, whichever you look at bottom, so that it was a bit rounded on the bottom. Well, SX, they built them flat because it was faster. I mean, trying to weld carbon steel and to get that. Okay. Well, then, lo and behold, here's this really hot waste, sludge, in the bottom of the tank. And, of course, the concrete has some residual moisture in it. It evaporated the residual moisture, and the tanks buckled up like this.
They cracked, right?
Well, and they cracks formed. I mean, they buckled up as much as 8 feet.
Wow.
Well, it's a 75-foot diameter tank.
Sure,
so,
yeah.
But, yeah. And so, yeah, that was another thing. Eventually, what they did was try to remove as much supernatant from the tanks that had it was 108 SX and 107 SX, I think.
So had they been concave, would they have buckled?
Yeah, well, likely not, because you got a lot of weight from the aqueous and the sludge, and so the moisture probably would have, under some pressure, worked its way out. But they were in a hurry.
Right. They got to have somewhere to put.
It's the Cold War. We're thinking we're going to be in a nuclear war with Russia anytime soon, and so.
It seems so. It's so interesting to me that now we've been in this cleanup mode for almost 3 decades, and it's the constant topic of conversation and planning for the future and worrying. And it seems like that's a complete opposite of the first 40 or so years when waste was always kind of the afterthought, and the idea was, well, let's just make more room so we can pack more of it down there, and we'll, it's always like we'll get to this later, like constantly tabled issue.
You just keep pushing it off because we have our short-term priorities.
Right. And I think it's hard for people now to understand how couldn't they have been planning, knowing the basic science of how long these radioisotopes would take to decay, but then also knowing the chemicals that were used in this process.
Well, one of the things that was explained to me, and it makes perfect sense, is there was no experience, no history.
Right.
Okay. So what they did is they followed standard industrial practice. If it's no good anymore, you bury it. Okay. Again, without the experience, what they had to go on was what had been going on for ever.
Sure.
In industry. So just transfer that to the nuclear side.
Right. No, it's perfectly rational in its own way, but it's also, I guess, with hindsight, it's like, wow.
Well, hindsight is always 20/20.
Right. It's kind of a scary rational decision in some ways.
Oh yeah.
So in 85, right? Before that.
75.
75. You went to work at
P&L.
This kind of new, and was vitrification a new? Was this kind of an emerging idea then, or was it already established for nuclear waste?
It was emerging.
Okay.
This was some of the work to support a DWPF, Defense Waste Processing Facility, back at Savannah River, which I became intimately involved with. It was, I spent a good part of my life working on waste vitrification design and startup.
And so the idea then, instead of removing moisture, putting it in the tanks, is to turn the waste into a solid and encapsulate it, correct?
It's a vitreous product, glass, and then, well, Savannah River is using these 2-foot diameter, 20-foot stainless steel that eventually the intent is it goes to a repository.
Right.
But, it's some of the early work looked at what's the place over in Africa where they had the natural reactor.
I can't remember. I know.
That's Oko or something like that.
Something like that, yeah.
Okay. Anyhow, what they'd found is that there was enough heat there that a lot of the material was vitrified. And now you go back thousands and thousands, hundreds of thousands of years later, and it's still there. It hasn't migrated. So, you put it in glass, and it's not going anywhere. So that was the early work. And what P&L was doing was chop leach of commercially irradiated, and from West Valley, as I recall.
And that's in New York, right?
Yeah.
Okay.
We brought them here, disassembled them, chop leached the fuel elements, dissolved out the.
So sorry, what was that word you just said? Chop leach?
Yeah.
What can you?
Oh, okay. What it did is there's and I did the design for this. The fuel assemblies are fairly complicated. Typically like a 12 by 12 array, but it varies depending on whether it's a PWR, BWR, and it has changed with times. But develop techniques to take the head plate off so you can get at the fuel rods. And then you had a little clamping device comes out and pulls it into a hydraulic press. So you pull it like 4 inches through, you chop out 2 inches. You pull it another 4 inches through, so you get two 2-inch pieces with each chop. Mm-hmm. And then it falls from there directly into a tank where you leach out or dissolve out the uranium, plutonium, whatever is there. And then that's going to be mixed with glass formers and turned into glass logs.
Okay. So this is done with the fuel rods.
Yes.
Okay. And so West Valley sent these rods to PNNL?
Yeah.
Okay.
West Valley was shut down.
Right.
And they didn't quite know what to do with the spent assemblies that were already there. So we helped them get rid of a couple of them.
Right. And was West Valley, was that those commercial power?
It was intended, to actually be a commercialization of fuel reprocessing.
Okay.
There were 2 places in the United States where that was supposed to be. That was basically a prototype. I mean, it was going to be commercial, and then the Morris plant, GE's Morris plant, which was in Illinois, Morris plant never got beyond early testing. They got it contaminated, but not badly. West Valley actually had processed fuel.
Okay.
And the problem there was that the powers that be kept changing the rules. They built the plant to the rules that existed at the time they built it, and then the government changes the rules, and they try to update, and the government changes the rules again, and they finally just sort of threw up their hands. And Bechtel actually was the company that built West Valley.
Oh, okay.
So they had some pretty practical knowledge of what was in there.
Sure.
In fact, I worked with a guy, Jack Nelson, who was one of the chief engineers on that. Yeah, and Jack is still alive down in the San Francisco Bay Area.
Okay.
He occasionally sends little humorous things to another friend of mine down there who shares them with me.
Oh, that's cool. So how come PNNL or PNL then? I guess it seems like there would be a national lab much closer to West Valley to send those.
Well, it wasn't initially to process West Valley.
Okay.
We needed fuel assemblies,
Oh, okay.
and they started casting around for where we might get them, and because the commercial reactors weren't necessarily. They still had the idea that they were going to be able to reuse them, and so we get them for free. Basically, I think the idea was we pay shipping,
Sure.
and
I imagine still is no small feat for used fuel assemblies.
yeah.
Yeah.
So anyhow, yeah, that's how we got.
How come that why was the decision made to start vitrification with this commercial or reprocessing fuel assemblies rather than something at Hanford, like one of the some sort of waste from Hanford?
Well, first of all, the Hanford waste, a lot of it was slugs. Okay, if you look at what was in B reactor, C reactor, the early reactors, there weren't fuel assemblies.
Okay.
What they had is tubes that they loaded metallic slugs in. I think they were like 2 feet long. But anyhow, if you go out to, about Burma B Reactor Museum Association.
Yeah, I'm a member, a board member of Burma.
Okay, well I'm a member. I pay my dues, but
okay.
Okay, so you can see there what the fuel slugs look like.
Yeah, we have some of those in our collection.
Yeah, the cold ones, but yeah.
Yes, we do not have hot ones. Let's just say that on camera. We do not have actual
radioactive material.
We have the testers and the displays.
Yeah. So anyhow, those weren't really conducive to, because we were looking for something that would apply to commercial nuclear fuel.
Okay.
And what existed at Hanford was, it wasn't going to be typical.
Wait, so these fuel assemblies then are maybe similar to kind of like the fast flux stuff, where they were these longer rods. Okay.
Well, what they were is, again, as I recall, don't quote me on this, but like 20 feet long, and a like 12 by 12 array, and there was spacers and cooling tubes, and it came as an assembly that would slip into a reactor.
Gotcha.
When they did their refueling.
Okay, thanks. I've all of my experience with reactors is without here most, so I kind of forget about I forget how different commercial is from or reprocessing is from the Hanford stuff.
And of course the commercial fuel is burned up a lot higher.
Right.
Because, and I'm probably telling you what you already know, but really you didn't want to irradiate the fuel too far at Hanford, because your 239 starts becoming 241, and pretty soon you wind up with something that won't go boom.
Right.
So.
But in commercial, you want that sustained.
You want to burn it up as far as you can.
Right.
Because you paid a lot for it.
Right. Yeah. No, I think that's something maybe that a lot of people don't understand, is how different those processes are. You don't make bomb material in a commercial reactor.
No.
It doesn't. It's the exact
opposite. Initially, if you take a fuel assembly that's just been installed for a few months and you pull that out, you potentially could process it to get enough the Pu-239 to go boom.
Sure.
239, 238, it's 239, I'm pretty sure.
Close enough.
Close enough for going to work.
Okay, so you started working. So 75 started working on this waste vitrification, and what was the outcome of the project? Was it a success? What did you produce?
I actually left before they actually. I designed the stuff, watched the stuff get built, and then I went off job shopping, and wound up back out at Hanford, working on low-level waste for Hank McGuire.
Okay, and how come you left the PNNL before the project got underway?
Okay, well, initially PNNL was a great company to work for. Ev Irish was the guy that was in charge of the whole thing, and there was an awful lot there that was totally novel, and he just said, "Figure it out." Yes, sir. I mean, that's so. I, for instance, was back Midwest checking on the press operators. Things like zirconium, which is was field cladding, but it is pyrophoric. So you do some research and say, we're going to be storing these casings. Had been reports of fires starting in zirconium. It's fun stuff. You get a casing and you scrape it along concrete and it sparks. It can be fun. But,
Sure.
But yeah. So anyhow, and they had flex time. You had to be there core hours, which was 10 in the morning to 2 in the afternoon. So I'm doing things like getting there at 6 o'clock in the morning and leaving at 2:30. Got my 8 in, and then I could get my boat out on the water, sailboat. It was great. I was given a lot of free rein. Then they decided they were going to pretty much production mode, and they brought this guy in from GE's Morris plant, who was pretty much the north end of Morris going south. And he said to me, "What hours are you working?" I said, 6 to 2:30. "Well, you need to work the same hours as everybody else." "Well, we have flex time." "Well, we're not going to have flex time." Okay, well, that's just one of the... He was a butt.
Sure.
And I had pretty much got my design in place, and I thought, let's do something else.
Sure.
I'm not a patient soul. I tend to be restless.
Right.
Next challenge. Thank you.
And okay, and so then you said you went and shopped. And when was this that you left?
I went back to work that was 76. I was there for a little less than 2 years. So I've been 77, 78.
Okay.
I went back out. Well, I didn't, I was signed up with Butler our day, and I thought maybe I'd go someplace interesting like Oak Ridge. But they wouldn't tell you where, it's a nuclear thing, and yeah, you see my resume, I can do that. And they said, okay, here's where you're going. And I don't think they looked at where I was at. And they said, if you have to commute more than 50 miles, then you get mileage. No, it's about 25 miles. I'm sorry. I don't get no mileage. But, I'd signed up, and it was good money. I mean, in the day, it was no real bennies, but $15 an hour in 1978 is, considering the minimum wage was considerably less than that.
Yeah.
So I did that for 6 months, and then because they couldn't hire you away from Butler our day until at least 6 months. And basically, as soon as my 6 months went in, here, sign here. Okay, sure. Yeah, I was apparently appreciated.
Oh, good. And so what were you doing? So you said after piano you left and went back to Hanford.
Low-level radioactive waste management.
Low level, and what is that? Just to break that down for me in layman's terms.
There's all sorts of sites where contaminated liquids and solids have been disposed of just in the ground. Okay, cribs, specific retention sites, things like where there was a canal from B plant that went out to Cooling Pond, and then they had to sell 8 incident B plant, which resulted in a large strontium release. And so now that canal is contaminated all the way out. And so what they do is they put a lot of dirt on it and dig a new one, and we move on. But now it's a low-level waste site. So there, as I recall, there was close to 400 of them.
At Hanford?
200 east and west.
400 of them and 200 east and west.
Yeah.
And this was just a mix of contaminated ground and...
Yeah, by liquids. Again, some stuff buried. It was a lot of liquids, cribs, and so forth.
And so the cribs
cribs and spills and...
Sure, and the cribs were just were these usually just like holding facility?
No, it's Basically, it was to dispose of slightly contaminated aqueous water. And the idea was that the Hanford soil is a very good ion exchanger, and the water table is like 300 feet down. So by the time this waste gets to the water, it's been cleaned up.
Like a natural filter.
Yeah.
But then
that leaves the ground contaminated.
Right, then the filter's contaminated.
Yeah.
Yeah. But not the water, but you contaminated the soil.
The idea was that nobody's ever going to live there, so, and, you know, they're not going to be punching wells down in 200 East, 200 West area.
Well, I would hope not.
Yeah. So, you know, that was, and I think I mentioned the specific retention sites, that with the stuff that they weren't sure could be held up by the soil column, they would pump enough liquid in to saturate the soil column without reaching the water table.
Interesting.
Of course, I have to tell you another little story from back in my early days in tank farm. There was a tank and sea farm, I want to say it's 103C, which was an OWW, that's Organic Wash Waste Receiver from Purex. Because Purex, as part of their process, used what they called NPH, normal paraffin hydrocarbon, and they liked to reuse that because it was expensive, so that they would aqueous wash it. Okay, and then the aqueous wash would go out to 103C. Well, there was some small amount of organic entrained over time, and then they were going to send 103C, pump that to as feed to my ITS2 unit. And you don't want organic in, you know, it was going to be above the flash point. So if you accidentally got organic in there, you could have a real nasty incident.
What such as?
Explosion.
Oh, okay. That's pretty nasty.
You get it up to the flash point, and then all it takes is an ignition source.
Okay. Gotcha.
Okay. So they had taken a sample of 103C, sent it over to the lab, and then said that sample was all NPH. What? Well, again, this is crude sampling. You drop a bottle down to the tank liquid, let it sink till it gets filled, and pull it up, and then rinse it off, put it in a lead pig, and send it to the lab. Okay. So they said, okay, that's not good. We don't want to pump that stuff to a hot environment. And so then I was given the task, this has been 1970, 71, of finding out how much organic there was in 103C. And I was given a magnificent budget of $250,000, which in today's money you could probably put a couple zeros after that. But
yeah.
And they were talking about things like radar and sonar and, okay. So now I have a problem. What to do? So I'm working graveyards, and, you know, what is the difference between the, let's see, the aqueous phase has a specific gravity of about 1.12. The organic is like 0.8, so there's a big difference in the density, specific gravity. How would you, Mr. Archimedes, buoyancy. Yeah. So I sketched up a little thing that would go through a 12-inch riser, plywood disc, appropriately weighted with enough lead plate so that it would sink, and then put an eye bolt through the whole thing. So I had this sketched up and went down in the bowels of B plant to the shops and said, could you build something like that? Yeah, where's your work order? It's just a piece of plywood. Why do it? Let me take a look at it. So about 2 hours later, I get a call. You going to come pick this up or not? Yeah, I'll be right there. Well, then I was too lazy to write a test plan, so I waited till the weekend, and my shift supervisor, who, as I recall, was Dean Curtis, known fondly as Curly because he was bald. Okay. So I said, this is what I want to do in Sea Farm. Can you get me a couple operators to... Oh, yeah, sure. So we took the riser cover off, had a tape and a fish scale, and lowered it down. And, you know, you can see when the as soon as you hit the liquid, the weight decreases pretty dramatically, and you keep lowering it slowly against the side of the riser with a tape, and then it gets a lot lighter as it hits the aqueous phase. Okay, and I had him repeat it, and I'm taking numbers now, and I had him repeat it 5-6 times just to make sure. It was good within half an inch, that we had like 11 inches of organic on top of the aqueous. Okay, and then yeah, let's clean up here. And of course now the tape is contaminated, the plywood disc and the lead are contaminated, and the operators are whining about, well, we're going to have to wash that down and bag it out. And I get the fish scale off. Oop! I dropped it. Oh my goodness. Ha ha ha. Mm-hmm. So it's in the tank. Okay, so we button it up, and I go back, write up my report, turn it in. Pissed my lead off to no end because I didn't spend any of the $250,000. But the point I'm making here is the tanks are generally seen as if you got something that you need to get rid of out in the tank farm, open up a riser, put it in.
Right, because it's all just so messed up down there anyway.
Yeah, we're never going to get that stuff out of there, you know. So why? So there were cement blocks. There were, you know, that I know of. Now that Lord knows what went in there that I don't know of. But
right. Wow.
Okay, but that's a ancestral story that you probably shouldn't let somebody like me work shift work.
It's a great story. Thank you. And so how long did you work as a low level waste engineer?
That was up until June of 1980, so probably close to 2 years.
Okay.
Yeah, we had a lot of that. We had a subcontractor, Ford Bacon Davis, down in Utah, Salt Lake City, and so a lot of what I was doing was going back and forth because they were supposed to be writing this massive report
on the low level waste
sites. Yeah.
Yeah.
And well, it turned out I probably wrote half of it myself because they had been chosen on the buddy system, I think. We had competitive bidding, and they changed the rules in order for Ford Bacon Davis to get it.
I see.
Nice people, but the one really good guy, shortly after we got into this, they sent him off to Washington, D.C. Okay. Paul something was his name. Mm-hmm. Good guy. But so anyhow, then we'd gotten that well underway. It was actually in DOE's hands for approval. And meanwhile, I was separated from my wife. I got involved with a young lady who was attending Mills College down in Oakland. And then ran across an ad in Nuclear News from Bechtel looking for somebody with vitrification experience, which I had from B&L. The next thing you know, I'm headed for Bechtel in San Francisco.
Oh, wow. What a change.
Yeah, it was. I had never lived in a big city before. Well, Rochester, New York, but I was on campus, you know.
Yeah.
So now I'm taking public trans. I'm, you know, and I was a serious runner at that point. And around here, you know, a good part of the year you don't have any races. And maybe you have one every month or so. In the Bay Area, there's races every weekend. And you can be really picky. I tended to pick the ones that had beer afterwards. Anyhow, I had a very lovely time working for Bechtel, a great company. Mm-hmm. They took good care of me. When I first moved there, they'd given me a raise, a little bit less than 8%. But basically the guy I'm directly reporting to, the chief technically reporting to, had said, you know, if Bechtel likes what you do, you're not going to be able to change jobs to your financial advantage. Okay. So when they hired me, I said, okay, I remember that. 6 months later, I got a 19% raise.
Wow,
So, yeah,
that's pretty good.
yes, it's a vote of confidence that, you know, so yeah, I like this.
That's great. And so you were doing vitrification work down there?
Yeah, doing the initial design work for a defense waste processing facility
At Savannah River.
at Savannah River, yeah.
And then you but you left San Francisco after a while, right? And you came back to Richmond.
Well, I was, yeah, it was about 5 years there, and we'd pretty much wrapped up. I wouldn't say wrapped up because we never wrapped up, but had the bulk of the design done, and they were going to shift things back to Savannah River. And being a process engineer, my engineering work tends to be at the front end, piping and instrument diagrams, things like that. And once I've got those out the door, then you're talking to your civil, structural, whatever people. So the job in San Francisco was winding down. That was in the mid-'80s. We were in a bit of an economic slump. There wasn't a lot of work in the Bay Area. DuPont said they wanted me to go to work for them back in Savannah River, because apparently they'd like me too. So then I filled out an application there, and my old boss up here, Hank McGuire, I'd put down as a reference, and he said, if you're looking for a job, why wouldn't you look here? Okay, I didn't know that. Oh yeah, you know. So, and then the wife was going to start an advertising agency. She's from the Tri-Cities, wife at that point, and said it'd be a lot easier to start an ad agency where you know the territory rather than going to the East Coast where, you know. So I took the job here in Hanford. So yeah, that was lots of fun.
And what did you do this time around?
Oh my goodness, what did we do? It was more back on the low-level waste stuff again. Trying to.
It says here in my notes that that Jillian wrote down that you came to work on the vitrification plant before going to Savannah River to work on.
Oh yeah, okay,
Yeah.
that's what. Yeah, earlier. Thank you for reminding me, because I'm going. No, at that point it was called HWVP, Hanford Waste Vitrification Plant, or as the Indian manager called it, HWWP. Had trouble with those V's.
Mm-hmm.
He's a perfect example of spoke good English, but idiomatic English, that's difficult.
Mm.
So we who worked for him kept a little quotable quotes, things like a whole new ball of games, and out in the boondoggles.
Ah.
Well, some of them were quite descriptive, I thought.
Yeah, that's pretty.
But he just was not doing well with idiomatic English, and he shouldn't have been trying. Anyhow, that's, yeah, HWVP.
And what is HWVP?
Well, that was just a precursor to vitrifying Hanford Waste. That was limited scope. They were not. The current one, Vit plant, is supposed to basically address all the tank waste.
Okay.
HWVP was focused on high-level waste.
And where was high level waste? Like, what defines high level waste?
Boiling waste tanks.
Boiling waste tanks.
Yeah. But it was, again, very poorly managed. It was supposed to be just a duplicate of DWPF. Well, DWPF nominally was built for $620 million. They were still pouring concrete on startup money, so the actual cost was closer to $1 billion. And now we're going to build HWVP for $620 million, just using the same drawings, which it was so incredibly stupid. First of all, source term for Savannah River for exposure was, for continuous exposure, is 0.5 MR per hour. For intermittent was 5. Okay. For Hanford, it was 0.2 and 2. different criteria. On top of that, the Hanford source term was roughly twice as radioactive as DWPF. So now your shielding is just not going to work. So you're going to have to redesign all your shielding, which means you're going to have to redesign all your embeds, which means and that's just one fallacy.
Sure. How come the radiation standards were so different between the two facilities?
Part of it is that, of course, DWPF was meant to support hydrogen bomb, and so the stuff wasn't burned up as far, and the waste wasn't as hot. Where Hanford, the boiling waste tanks were screaming hot. Purex was a very good process at minimizing the amount of aqueous waste you produce.
So it's all concentrated.
Yeah, and screaming hot.
Screaming hot. Because you've concentrated all those isotopes.
Yep.
And once you've removed the water, the aqueous.
Yeah, well, move some of it.
Some of it,
yeah.
Right.
So yeah, the boiling waste tanks were self-concentrating.
Because the heat keeps evaporating
liquid, and it boils, and you have to deal with so you've got condensers on the off gas, and of course the HEPA filters, but yeah, source term, and these source terms were very conservative. They looked at the worst stuff we had in a boiling waste tank and said, you got to design to that. And of course, we engineers said, well, why wouldn't you mix that with, we don't know that can be done or will be done. You have to design to the highest possible. Right, okay.
And so given these challenges, what happened with the Hanford Waste Vitrification Plant? Did it get built for?
Oh, no. Nothing ever. It just kept getting screwier and screwier. So eventually I wound up back at Savannah River. Took a temporary assignment there with Bechtel. Well, story here. I'm working happily, getting paid happily, okay, here at Hanford. And Westinghouse was the contractor at that point. And so they put a notice up on the board that Westinghouse had gotten the new contract at Santa River. And of course Bechtel was a subcontractor to them in the announcement. So there was a good friend of mine with Bechtel in San Francisco, Vic Kiak. So I picked up the phone to call Vic and congratulate him. And no answer. So I just hung up the phone like this, and it rings. I pick it up, and it's Vic calling from Savannah River. Well, they're going to have to be staffing up because DuPont's engineers are leaving. Westinghouse is not taking over that part, and so Bechtel is supposed to pick that up. And do I know anybody who might be interested in it? At that point, I was rather frustrated with HWVP, and I said, talk to me. And so they did, and so I went back there on a temporary assignment. And then along in there got divorced from a second wife, and so then, rolled over to a permanent position there at Savannah River, and I went back there as EGS, Engineering Group Supervisor.
Okay.
So I had as many as, 38 FTEs reporting to me. FTEs, full-time equivalents.
Yep.
Okay.
Been here not that long, but long enough to have picked up some of the acronyms.
Okay. So then after I had that, I was at that for a couple of years, and then they moved me up to task manager, which is multidiscipline. And then I ran a project thing, late wash project design, conceptual design report, which typically was going to take 2 years for novel technology. They said, you've got 6 months. We got it done.
Wow.
And then I was manager of design completion engineering. I forget what the title was, about this long. No more money, but the title was about it. So, yeah, that was And then again, that job is winding down, and they say,
As the plant was being built.
yeah,
Yeah.
and so they say, "Oh, don't worry about it. You'll be the one turning out the lights." No, I don't see myself as an electrician turning out the lights. So then I transferred back to Southern California, and they supposedly had a couple of things they're going to, because I'm a professional engineer in the state of California, and there isn't that many professional chemical engineers. It's a rather rigorous exam to do that, like all day.
Wow.
2 4-hour sessions.
Wow.
Pass rate the year I took it was 27%. Okay, so they thought I would be valuable. Well, they were going to have me on a clean air project with ARCO, and ARCO delayed that part of it. Then they had another one that, oh yeah, we got this one in the bag. They didn't get it. And then, so now I'm looking at another. I'm scrambling to find a couple hours a day worthwhile. And there's another friend of mine that was a honcho with MacTech, and got hold of him and said, how are things looking? And he said, want to come to work for us? Potentially. So I wound up here with MacTech. It was in '93.
And what did MacTech do?
They were supposed to be in-house consultants to DOE.
For?
The entire site.
Oh, okay.
What eventually it turned into is staff augmentation for DOE, which wasn't supposed to be the way it was done, but DOE needed people, and the funding process was not getting them what they needed to hire people directly, so they used MacTech. So yeah, worked at that for a couple years.
And what did you do there?
Basically anything I was told to do, but a lot of document reviews, things produced by the contractor.
Okay.
I did one time or another little corporate story here. I was on a team that was reviewing the safety analysis for a new tank farm, and they made the flat-out statement that they covered all the safety aspects. And I said, bullshit. You don't ever use absolutes like that, because there's always going to be something you didn't think of. Oh no, they thought of everything. I said, well, let me tell you something you probably haven't thought of. You allow pickup trucks to drive out in a tank farm, right? Yeah. You have risers down to the tank. The tank's under a slight vacuum, so there's air leakage in through the riser. It keeps the contamination from spreading, yeah. I said vehicles have been known to develop gasoline leaks. So now you have a pickup out in a tank farm, parked over a riser, leaking gasoline, the fumes are being drawn into the tank. How long does it take before you have a flammable mixture in the tank? Oh. I said, no. I said, you can do that. Talk to maintenance. How often do they have to fix leaky fuel systems? You can come up with some odds on this. Well, then my part of the thing was done. We'd done our review, and I had scolded them for, don't ever tell me you've covered all the safety things. Okay. Well, they never built a tank farm. They decided that they were going to be able to get by with space recovery programs, whatever. Then it was a couple years later, I was telling that story to a group of, well, it was actually, I think, AICHE meeting. And this one lady said, you. What? Well, it turned out that they had taken my scenario very seriously and banned trucks from driving out in tank farms. And so that makes things definitely, well, you need a special permit. Used to be you could just drive in areas that weren't contaminated, and then you had to have a special permit and fill out all sorts of paperwork to get a truck out in a tank farm. And she thought I was the cause for all that extra work. Anyhow.
Oh, that's awesome. And so you were kind of like a consultant for Tank Farm stuff?
Mainly it was tank farms, yeah, but it was whatever was going on, documents produced by the contractor or oversight of problem solutions.
Okay.
You know, report back to DOE, how's this going?
Sure. And then it says here that then you went back to the VIP plant.
Yeah.
Here.
Well, again, that was a bit of a segue. I got a call from San Francisco and said that Westinghouse had a RFP out, request for proposal,
Mm-hmm.
for close to $1 billion in tank farm upgrades over 10 years. And they wanted me to be like a one-man office here to spearhead that till as things got underway. So, and they bumped me up to a grade 28, you know. Okay, sure, why not? I mean, it wasn't that I didn't like working for MacTech, but, you know, this seemed like a great opportunity. So, yeah, I took over and had a little office downtown, you know, and then
in San Francisco.
No, downtown Richland.
Oh, Richland.
Yeah, right there in the Parkway. So then Westinghouse started fudging, and they finally took the RFP off the table, said they'd do it in-house. So now I'm up here, and so they said, and BNFL had the vitrification contract at that time. Bechtel was seconded to them. And so they said, you can either roll over to the VIT plant or you can come back to San Francisco. I said, San Francisco, been there, done that, got the T-shirt. I think I'm good. So I went to work on the Hanford waste vitrification.
And what year was that?
Let's see, back up here. That would have been 96, 97.
Okay. And where was the VIT plant at that time?
Early design phases.
Early design phase.
Yeah.
And how long did you stay with the VIT plant?
Oh, gee. Basically until I retired. Of course, initially it was BNFL lead, which got a nice trip over to Sellafield in the UK, and I do love British beer. And the Lake Country is where Sellafield is, pretty country, and got to see what they were doing for vitrification. And I'm, okay, I see a lot of mistakes here, but, well, we learn from our mistakes. Okay, well, eventually DOE got disgusted with BNFL because the cost kept going up.
Mm-hmm.
It's still going on today.
Yeah.
Costs keep going. Anyhow, so they basically fired BNFL. So then I went to work for basically a job shopper here for like 6 months. Stayed on the job, but not with Bechtel. And what was the name of that? Can't think of the name of it. It was a brief period of time while they rebid the contract, and of course Bechtel won, and then I'm back working for Bechtel.
Mm-hmm.
And so, yeah.
So how far did the VIT plant get from when you started to when you retired?
Well, they'd broken ground. I really don't recall. I mean, I know that they were working on it, but a lot of it was the structural stuff,
Mm-hmm.
which, from a process point of view, I wasn't involved in. I was still just doing a lot of design,
Sure.
or helping with design for the process part of it.
What are your views on the current situation of the vitrification plant?
Over-designed. They're, trying to make it do everything, and they keep changing the rules. And then they're surprised when the cost goes up. As a friend of mine said, generally there comes a time in every project when you have to take the engineers out and shoot them and just build it. And they never got to that stage yet.
Oh, I see. Makes sense.
Well, it's the administrators that need to tip it. Anyhow.
Right. So last question. What would you like future generations to know about working at Hanford and living in Richland during the Cold War and afterwards?
Oh, gee. It's very great community. I mean, because of overall wages are high, the overall education level is high, schools were good. It was just a great place to raise a family. In fact, a lot of people stayed here unhappy with the job, but because it was good for their family, they said, okay, I'm getting a paycheck, it's good for my family, I'll hack it. So yeah, it was just a great place to raise a family. And both my kids are still here.
Okay.
Yeah, my son's a Kennewick firefighter, and my daughter works for the state, basically overseeing the payments to the people on welfare, basically.
Oh, okay.
So anyhow, yeah, two grandkids here. One of which, well, I have to brag a little bit. It's off the subject, but my son had been coaching soccer since his daughter was like 6 or 7 years old, club soccer. But so last summer, and she's now was going to be a sophomore, and the AD out there kind of Benton said, "We'd like you to be the girls soccer coach." And he said, okay. And, oh, by the way, it pays $4,500. He said, if they hadn't told me that, I'd probably done it for free. But anyhow, so the year before that, the soccer team won 3 games. This past fall, the girls were undefeated in league, took the SCAC championship, but lost their first game at state. So I think they were sort of burned out by that time. But anyhow, my son then got coach of the year for the league, and my granddaughter was selected as MVP for the league.
Oh, that's great.
Yeah, so great place to live.
Yeah. So, Ted, is there anything that we haven't touched on that you'd like to talk about today? All right, well then I think that's a great place to end.
I mean, this could go on for a long time. But,
Sure.
But I think you've got highlights and...
Yeah, we got some really great stuff here. I think thank you for kind of really illuminating the waste processing, history at Hanford.
Yeah.
Appreciate it.
Well, and the successive companies like Arco, basically the guy they had leading it here had not been doing well in their primary business, which was petroleum. But now they win the contract here, and they got a place to stick him. And so he didn't provide strong leadership. And that was sort of they win the contract, and here's a place to park people.
Mm.
Oh, well.
Oh, well, thank you so much, Ted. I really appreciate it.
My pleasure. Oh.